All right, hello, this is Mac, and this is Prime Factorization version B. You can find a video and version A where I talk maybe a little bit slower about this at maxtutorials.com. If you haven't visited that, you can see a lot of really cool videos and worksheets and ways that I can really help you through your algebra class, okay? But in any case, we're going to go right here to version B, and I'm going to go a little bit quicker. A prime number is anything that can be timed, that can only be times by itself and 1. 18, I can break that down. I'm going to go 6 times 3. I can't break down 3 anymore, so I'm going to circle it. 6 can be broken down to 3 times 2, and those can't be broken down anymore. So my answer is 2 times 3 times 3. Let's go 40. When I see a 0 at the end, I always multiply by 10. Though you could see that as 8 times 5 and some other things, but let's get used to zeros using 10. 4 can be 2 times 2, and a 10 can be 5 times 2. And I end up with 2 times 2 times 2 times 5. All right, 54. It's a couple different ways to do this. You should see this as 9 times 6. But let me show you a few different things. You see it as an even number, so you can multiply by 2. That'll work. But also, you see 5. If you add the digits, 5 plus 4, you get 9. If the answer when you add the digits is divisible by 3, then this is divisible by 3. I can go 3 into this. So I can break this down to 3. Well, 3 times what? Let me zoom in here. Well, 3 will go into 5 one time with how many left over? With 2 left over. How many times will 3 go into 24? 8 times. Okay? 3 is done. This becomes 9 times 2. That's done. That becomes 3 times 3. Done, done. 2 times 3 times 3 times 3. Okay? Just by looking at, again, go away. 2, 3, 3, 3. I look at all my circles. So always circle them. Ooh, guess I shouldn't have circled that 9. Oh, well. 6 times 3. Hopefully you see that now as 9 times 7. Knowing your multiplication table, that's 3 times 3. And I'm left with 3 times 3 times 7. Let me zoom out so I can see what I'm doing. 75, if it ends with a 5, put a 5 in there, okay? So this would be 5 times what? Well, how many times will 5 go into 7? Once, with 2 left over. 5 will go into 25 5 times, okay? Circle the 5. 15 is 3 times 5. Circle, circle. 3 times 5 times 5. 96. Well, I can see that a 3 will go into 9 and a 6, so let's start there. 3 will go into 9 3 times. 3 will go into 6 2 times. 3 is a prime number. This becomes 8 times 4. 4 becomes 2 times 2. 8 becomes 4 times 2. And 4 becomes 2 times 2. Whoa, see why I'm circling them? Now, how many 2's do I got here? 1, 2, 3, 4, 5. 2 times 2 times 2 times 2 times 2 times a 3. Another way to write this, you could also do this. 2 to the 5th power times 3. There's just another way to do it. They're both right. 108. Well, I see it's an even number, so let's just go 2 into it. Here's a quick little division thing. How many times will 2 go into 10? 5 times. How many times will 2 go into 8? 4 times. All right? 54, hopefully you see that as 9 times 6. Hopefully you see the 6 as 3 times 2. And hopefully you see the 9 as 3 times 3. It got a little busy. Let's start with the 2's. A 2 and a 2. Now I have a 1, 2, 3 3's. And I'm done. 144. Hopefully you see that as 12 times 12. This will become let's go 4 times 3, and 4 is 2 times 2. I know this 12 will be the same as this 12, so this is 2 times 2 times 3. That's not a shortcut, that's just reading what it says on the other side. Now, how many 2's do I have? 1, 2, 3, 4. I have 4 2's. And I have 2 3's. Or 2 to the 4th times 3 squared. Okay, so there's a little bit about how to break down primes. Again, you're wondering why, and it comes later, mainly with what we call just, realizing some square roots or radicals, and also with finding greatest common factors. It's good to be able to do this. So if you're good on version B, awesome. If you want a little more help, I have a version C. And so I'll see you guys there. Don't forget to like and subscribe, and you guys keep plugging away.